Looks like he's reading it for the first time. Jason.
So, it says that there are 7 members on the board of directors. So
Yes.
The total is 7, which is going to be 10.
Yep.
And there are 4 different positions that we're trying to see.
4 different.
So you're going to do 7P4.
7P4.
Comes out to be
840. Okay. Everybody good with that? Now, let's say you forgot about the whole the permutations thing, right? How else, because I always want to keep in mind that it's actually pretty easy the other way too. How else could I have done it? There are 4 positions to fill, right? How many options are there for president?
4.
Well, initially, 7. Once the president's chosen, then we have 6 left, right, for the vice president. Once that's chosen, then there's 5 and then 4. So if you do it this way, you should get the same answer. Okay? Make sense? All right. Example 5a, I'm going to just say it's similar. It's good for you to go back and read this. Really, it's just a matter of can you count how many shows there are in here? Okay? And then they're telling you that you're rearranging 6 of them, so that's not too hard. What I do want to focus on is actually here. Okay? So let's say we have the letters S, E, and T. When we do the whole, if I'm rearranging these, let's say these represent books, like a social studies book, an English book, and then a technology book or something like that. So maybe we can think of it that way. And you're lining up or rearranging those books. There would be 3 choices for book number 1, 2 choices for book number 2, and that's where the 6 comes from, which is exactly what this is saying. Yes? Now that's because they're all different, right? These are the 6, if you actually wrote them out, these are the 6 ways that you can rearrange these letters to produce a different order. Okay? But now what happens, let's turn the page, if we repeat letters? In other words, what if I have duplicate books? Or duplicate items, okay? See if you can just count. So we know there's going to be 6, but what are the 6 permutations? Can we find them? So take a minute. How could you rearrange those letters? Yes, that counts as 1. Can you come up with the 6? Michael's saying, nuh-uh. How many are we coming up with? 3. Should only be 3. A-N-A, A-A-N, and what's the other one? And no matter what else you try to do, you're going to get one of these 3. And that's the key. So this should be permutations, not permutations. I think whoever typed this had a little error there. But permutations of duplicate items, you have to figure out a way to remove all those excess arrangements that are repeats. Okay? And so here's how to do it. In this example, there are 3 letters. So you're going to do 3 factorial in the numerator, because that represents the 3 times 2 times 1 for arranging if the letters, if they were all different. Okay? But because there are 2 letters that repeat, mainly we have 2 A's, you're going to divide by 2 factorial, because that would represent the number of positions that you can put the A's in, and then flip-flop them, and it's the same. Okay? Does that make sense? So what you're doing is essentially 3 times 2 times 1 over 2 times 1, which is just 3, which is the 3 that we figured out up here. Does that make sense? So, to summarize, when there's duplicate items, in the numerator, we do the total number factorial. And then the numbers on the bottom, these each represent the number of repetitions factorial. So for example, if we go to example 6a, Mississippi, that's a lot of repeated letters, right? Okay. But how many letters are there total? 4 letters total? Oh, I see what you're saying. There are 4 letters, yes, but how many letters make up the entire word? 11. Okay. So it's 11 factorial. Okay. But that obviously is way too many because you can flip-flop these S's and P's and I's, and we have to divide all those out. So here's how we do that. I usually just go one at a time. Does M show up anywhere else?
No.
What about this I?
Yes.
How many times?
4. 3 other times.
So a total of
4.
4. So that means we have to divide by 4 factorial. Because if you imagine those I's being different, there'd be 4 times 3 times 2 times 1 different ways that you can rearrange those I's, but they're technically all the same way. Does that make sense? What else repeats? How many times? So we have to divide by 4 factorial again to represent the S's being counted too many times. And then what's the last letter that repeats? And that has to be 2 factorial then. So let's figure that out. What's that going to be? Please try this on the calculator. You'd be surprised how many people get it wrong.
I calculated that.
All right, what are we getting? 34,650 is correct. I have a feeling. I think I do. You probably did 11 factorial divided by 4 factorial. You need parentheses around the entire denominator. Otherwise, what it's going to do, it'll do 11 factorial divided by 4 factorial, but then it takes that number and now starts multiplying by 4 factorial and 2 factorial. So either do it one at a time, or remember alpha y equals is still your friend. Get that little fraction template to pop up and then just fill it in as you have it written on your paper. Okay, does that make sense?
Yeah.
All right, let's make sure we get this last one right and then we're done with notes. Read example 6b, take 30 seconds, figure it out. All right, Andy, chance for redemption.
Oh,
Yeah,
Monday.
so, the
7
7
factorial, yep.
and then divided by 2 factorial 3 factorial.
Good. And what was your answer?
420.
That is correct. Are we getting these?
Yes.
Fantastic. So,